Welcome back. In this lecture, we're going to discuss how a classification approach can be used for regression. And that's the objective for this lecture. So, the intuition here is many popular classification packages have a regressor version. And if you look at scikit-learn, you'll see there's random forest classifier and random forest regressor. And same thing goes for decision tree. And also this is true not just in scikit-learn, but in many other machine learning libraries as well. Now, why would you want to use that instead of a regression-based model? Well, some of these, specifically random forest and decision tree, do not rely on fitting a parameter-based structure to the data. So it gives us a very different approach, and it may, in some cases, not overfit the data so much, and it can still be used for regression. Now, one little side note here is this, when I talk about random forest and decision trees and how they could be used for regression and how this is an advantage because they don't have parameters, I'm kind of excluding these gradient-based variants of them, which they can also be used for this as well, but keep in mind those do have parameters. So let's do a simple example. So here's a sine curve. So we generated this data to resemble a sine curve, but added some noise so it looks like some samples. So it's a non-trivial thing to have a model fit to. Now, of course, linear regression is not going to perform well. It's probably going to draw like a straight line or maybe something with a negative slope to catch that downward slope, but it's going to miss everything before around the x-axis of the 1.5. And here is a decision tree model that is learned to fit the sine curve. Now notice what we're doing. We have a single feature, which is the x value. And it's just taking a look at what that feature is. And it's attempting to make these splits in a way based on the mean squared error as opposed to, say, the Gini index or entropy. So it's using the same notion, it's just using a different function. So at each split, it's looking at a smaller number of samples, just like the decision tree would. And it comes up with a value for what it thinks, what the regressor should return if it has that value. And at the leaves, that value is actually what you get. So there are now 4 different values. So this gives you a very discretized regressor, but one way to address this problem is simply to allow for a decision tree with that is much deeper than the one shown here. So we can actually plot what that looks like compared to the sine curve, and even though it's highly discretized, we see it actually fits the curve in a pretty nice way. Probably much better than a regression algorithm would do. So anyway, just a quick discussion on how a classification approach can be used to address a regression problem. Please stay tuned for more content.